Hello! In this video, we're going to go through how to do coefficient alpha in JASP. So in this scenario, we have collected data using the statistics anxiety in an online or hybrid setting survey, and we'd like to check the reliability of the survey subscales before moving forward to analyzing the data. So which test should be used to analyze this data? Coefficient alpha should be used for this scenario because it could be used to test the reliability or internal consistency of a group of variables in a subscale. This measure provides a simple way to see if a score is reliable or not. It is used under the assumption that you have multiple survey items measuring the same construct, and that is important. If your survey is, let's say, a 5 or 10 question survey, but the questions are all measuring kind of different aspects of the construct, and they're not all measuring the same type of thing for that construct, then this is not going to work. So for this survey, the subscales are PC, preconception, CI, class and interpretation anxiety, FA, fear of asking for help, and OS, online system anxiety. So the first step is we are going to run the statistical analysis in JASP. So if you already have this in an Excel file, it is easier to go ahead and edit or tweak as needed in the Excel file and then save it as a CSV file type. If you don't have it in an Excel file, you can feel free to go ahead and create it manually in JASP. But if this is data you're exporting from somewhere or you have provided to you, it's far easier if you need to tweak or adjust things to do it in Excel. So once you have that set up, you're going to open that Excel file in JASP, which I already have opened right there. So there's the file. Do note for this assignment or for this example, we're using the factor analysis statistics anxiety data for this example. So once you have it open, we are going to go through and calculate coefficient alpha. So to do this, first of all, we are going to go up to reliability. If you do not have this reliability option, then click on the blue plus over here in the right-hand corner and scroll down and make sure this reliability option is checked. So if it's not showing up, it's probably not checked. So just go ahead and check it off, and then you'll get this wonderful option right here. Then you can click on it, and we do want classical unidimensional reliability. So we are not doing Bayesian, we're doing classical unidimensional reliability. So once we click that, the next step is we are going to add just the questions from that first subscale. So we're not looking at all of the subscales at once. We're not dumping all of these questions in. We are just doing one subscale, which in our example is the PC subscale. So we're going to go ahead and select them and move them over. Now, once we do that, we need to come down here, and right here, right, we don't want that one. We want to uncheck that one and instead check coefficient alpha. So that little symbol right there is alpha, and that's the one we want. And then we want the coefficient alpha if item dropped. So those are the two things that we want to have, and that's all we need right now. So if you are copying content over for your quiz or for your week 6 assignment, this would be the initial information that you would need. But what do we do with this? So if we come back over here, here we go. And so review the statistical results. So first of all, how do we interpret the coefficient alpha? And that's in this estimate. So what you're looking at is the estimate value. So you're not looking at standard error, we're not checking out the confidence interval, we're looking at the coefficient alpha estimate. And in this case, it's 0.865. Now for a 0.65, how to interpret that, if alpha is greater than or equal to 0.70, the subscale is considered reliable and having high internal consistency. So in this case, yay, it's got high internal consistency. If our alpha was less than 0.70, the subscale is not considered reliable and does not have high internal consistency. Oh, there we go. So in general, the higher the coefficient alpha value, the better, because it indicates that the subscale has high internal consistency. Internal consistency just means that the subscale questions or variables are measuring a similar construct. So for example, they're all measuring happiness, anxiety, leadership. In this case, because it was the PC subscale, that preconception subscale, what that means is that we have high internal reliability, that all of the questions for that subscale were measuring the same thing. So that preconception. So they were all measuring that same thing. So really important though, if you happen to have a note under your estimate results, and I don't have an example of this, so I had to kind of pretend it in here together. But if underneath your coefficient alpha and your estimate, if there is a note that says the following items correlated negatively with the scale, and then it lists what question or what variable, so in this case it was PC23, what that means is that you do need to reverse scale that item. Because what that note under your estimate results indicate is that the items are correlated negatively with the scale. It means you do have to rescale that specific item before you know what the true estimate is for this subscale. So what does that mean? It means that if you have this note, and like I said, I don't have a good example for these videos. If you attend or watch the recording of the live session, I do have an example where we do have this note and I am able to talk through it. So if you are like, wait a second, I really want to see this, then please go review the live session, or if it hasn't happened yet, then attend the live session and I will go through this. But very important, if you have this note, what that means is that your true coefficient alpha is not 0.865. You won't know what your true estimate is until you reverse scale whatever question, in this case it's PC23, until you reverse scale that item, you will not know what your true coefficient alpha is. So very important, if you get this note, as soon as you get that that initial value, next thing you need to do is immediately reverse scale. Like that is step, as soon as you run it, immediately if you have that note, you have to reverse scale because nothing else will be correct until you reverse scale. So very important. How to reverse scale, it's this wonderful option right here. And if we really did need to reverse scale PC23, we would just click on it and move it over there. Now you can see that note. So now it says the following items correlated negatively with the scale. And that's just because we reverse scaled it. So that's the note you're looking for. And if you had that note, that's when you would come through and reverse scale PC23. Now in this case, it's looking all weird because it's like, wait a second, it's not really reverse scaled. So it's kind of telling us, please undo what you just did. But if it did have that note, you would reverse scale just doing that. But for now, we do have our 0.865. It is considered reliable, but what is the next step? So the next step is, what do you do with the if item dropped table? So that's this table right here. So you can see coefficient alpha if item dropped. Similar to the table on top, we're only looking at these estimate values. And what we're looking to see, is there an estimate value for one of these questions that's bigger than our coefficient alpha estimate up here? So you see 0.865, and so what you're looking for down here, is there a number bigger? And this is really important. You want to know, is there a number bigger than 0.865 in this estimate table right here? Now if you go through, 0.788 isn't bigger, there you go, 0.868 is bigger. 0.826 is not bigger. 0.810 isn't. But this one is the biggest. So 0.873. And what you're looking for is the biggest one on this table, the biggest estimate. And in this case, the biggest estimate is 0.873 for question PC27. If you take that 0.873 and you compare it to your 0.865, if this 0.873 is bigger than your 0.865, then what you need to do is remove PC27. And that's really important because this is the if item dropped. So what this table is telling you is if you remove PC27, your coefficient alpha estimate is going to go up to 0.873. And remember, our whole goal here is we want to see, how can we improve our reliability? Also, as a side note, we really want the fewest number of questions we can that still have the highest reliability. In some cases, like if you're already using a pre-designed survey, For your dissertation, you can't just go dropping questions and that type of thing. But if you were doing survey design, say, for example, what you're going to be doing in week 6 for your assignment, you want to see what's the highest reliability you can get with the smallest number of items. So in this case, we want to get rid of PC27 because we want this estimate to go up. So if we take PC27, we're going to remove it, and yay, see, it went up to 0.873, but we're not done because we want the highest value we can. So we're going to come back down here and look at the table, and now what's the highest item estimate? Looks like 0.882 is the highest estimate. We're going to compare that 0.882 to the 0.873, and in this case, the 0.882 is bigger. So we're going to go ahead and remove PC24 because that's going to give us an even bigger. So now we're at 0.882, but we want to keep going. So let's look. And in this case, PC25, if we remove that, it'll get us to 0.888. And if we compare that to our estimate, 0.882 is smaller than 0.888. So we're going to go ahead and remove PC25. And woohoo, so our final coefficient alpha value is 0.888, and at that point we can't remove anything else, and we're at our highest coefficient alpha. So our highest coefficient alpha is this 0.888, and it would be with just PC23 and PC26. So with those two questions, we can hit our highest reliability for that PC scale. So back over to here. I have it explained here, but I basically just did it. So I'm going to go ahead, scroll down. So how do we write up these results? So for the written results, coefficient alpha was checked for the preconception PC subscale of the statistics anxiety in an online or hybrid setting survey. For the preconception subscale, coefficient alpha was 0.865. Now remember, that was our initial alpha value. A coefficient alpha greater than 0.70 is considered acceptable, so this subscale was found to have high internal consistency. To improve the internal consistency of the PC subscale, JASP indicated that removing PC27 would increase the alpha value to 0.873. And so this is where I'm documenting exactly which questions I removed and in which order to kind of show the progression of how I got to that highest alpha value. Reviewing the if item drop table next indicated that removing PC24 would increase the alpha value to 0.882, and then removing PC25 would result in a final alpha value of 0.888. So yahoo, those are our written results. That's how we would write up for this one right here. So these results that we just talked about, that's how we would go ahead and write those up. In the next video, I'm going to go ahead and talk through the rest of those write-ups.